Hello everyone. Today I'll talk about NZCV flags and conditional codes. So mainly I use here, I will give information about four conditional codes: greater than or equal, less than and less than or equal. So the main objective of this presentation will be to explain what are the NZCV flags and how they work. The second part of the presentation will be devoted to how to apply NZCV patterns for each of four conditional codes, and I'll use examples. I'll write examples using 8-bit patterns in order to make it more understandable for you. Let's begin from NZCV pattern. NZCV pattern, as you know, it's mainly used in Advanced RISC Machine 64 and branching in ARM 64 is controlled by arithmetic logical unit flags, which is also stored in global condition flag register, which is called NZCV. So these flags, let's continue with these flags. N, it means negative, 0, Z means 0, C it means carry, and V it means overflow. Negative, negative when we make operation of two numbers, and if the result of operation of two numbers will be negative, so we'll assign 1 to the negative part and 0 for other parts of this operation of the flags. So let's take an example, 12 and 15. When we subtract these two numbers, so the result will be 3, which is negative. So we will assign 1 to the negative part and 0 to other parts. 0. 0 is, we will assign 1 to the result of the operation, and let's take also two numbers, 20 and 20. So when we subtract these two numbers, the result will be equal to 0, and we will assign 0 for the negative part, 1 to the 0 part, and zeros for the carry and overflow parts. Let's continue from the carry. Carry, it means like when we take positive and negative number. Let's take positive and negative 8-bit numbers. 0, 1, 1, 0, 0, 1, 0, 0. When we add negative number 1, 1, 0, 0, 0, 0, 1, 1, 1, 0. So the result will be like 1, 0, 0, 1, 1, 0, 0, 1, 0. So as you can see here, there is an extra binary number, which is 1. So this will be carry. So let's say the formula for the carry is like when we add positive number and negative number, so the result will be positive, but also there will be additional number. So this is the carry. This is how carry works, carry flag. And what about overflow? Overflow, the main formula for the overflow is positive plus positive will be equal to negative. So let's see an example. 0, 1, 1, 0 plus 0, 1, 0, 0 plus 0, 0, 1, 1, 1, 1, 0, 0. So the result will be like that: 1, 0, 1, 1, 0 0 0 0. So as you can see here, after the addition of two binary numbers, so the result is negative. Numbers are positive, but the result is negative. So this is how overflow works. So while talking about NZCV patterns, I should also mention that NZCV patterns only used while adding S to the command, let's say. So when we write add R0, so let's say move R1 4, move R2 5, and when we add these two numbers and store the result in R0, so this addition will add these two numbers, and it won't add any flag to the NZCV. But when we use add S R0 and R1 R2, so this will update the flag. Why? Because the result of this operation will be stored to the CPSR, current program status register. And furthermore, while talking about NZCV patterns, I mentioned the branching. Let's talk about branching. So branching is about changing the normal sequence of the instruction execution. So let's clarify it. It skips the other instructions, next instructions, and will jump directly to the address, to the result address. So there are two main types of the branching: unconditional branching and conditional branching. Unconditional branching, it means that it will directly go to the resulting address without checking conditions, if this condition is true or false. So let's see this example. So I used here unconditional branching. So as you can see, so we will assign 5 to the register. Yeah, as you can see here, it skipped this instruction. Why? Because we use unconditional branching. If we use conditional branching, so it will go and check the condition if it's true or not. So I'll explain the conditions a little bit later. So as you can see, as a result, it will subtract 1 from the 5, and the result will be 4. So this is the unconditional branching. So what about conditional branching? Conditional branching, if it will skip the next instruction and go to the resulting address if the specific condition is true. So the first condition code which we'll talk about is greater than or equal. So as you can see, I used here an example. So I used here two numbers. I assigned 50 to the first register and 20 to the second register. So I will subtract these two numbers and assign the result to the 0 register. So there is a branching, conditional branching. As you can see, this conditional branching will check if R1 is greater than R2. If it's true, so it will assign 1 to the third register, else it will assign 0. I used here an example. Here. So let's run this program. And as you can see, it assigns 15 to the first register, 30 to the second register, and it will subtract 30 from 15. So as you see, the result will be negative, and it will assign 0 to the R3. So as you can see, it didn't assign 1 to the R3. Why? Because our condition was false, so 15 was less than 30. So for this reason, it assigns 0 to the R3, to the third register. So let's continue with less than condition code. Less than condition code, here is an example. So I use here also two numbers, negative 10 and 20. Negative 10 is assigned to the first register, 20 to the second register. And when we subtract these two numbers, if negative 10 will be less than 20, so it will assign 1 to the third register, otherwise it will assign 0. And let's see an example here also for the less than. There is an extra example for you in order to understand. So the first number, negative 10, assigned to the first register, 20 to the second register. So we will subtract these two numbers, and if the result, if the first register will be less than second register, so it will assign 1 to the third register, otherwise it will assign 0. Let's run this program. Here. So as you can see, it assigned 9 and 20 to the second register. Yeah. So when we substitute these two numbers, the result of this substitution, the result of the subtraction will be assigned to the R0, and as you can see, yeah, and it will assign 1 to the third register as a result of this operation. Why? Because we see here that 9 is less than 20, so for this reason it will assign 1. Let's continue with greater than or equal, greater than. So here is also an example. I use here two numbers, 50 and 20. So I will subtract these two numbers and assign the result to the 0 register. As I mentioned before, I used the S here in order to update the NZCV flag. So it checks the condition if R1 is greater than R2. So if it is correct, if it's true, so it will directly go there and assign 1 to the third register. So it will skip this part. So let's Yeah, 50 and 20. I will use another number here. So in order to 13 and 2. So let's run this program. So as you can see, 13 is added to the R1 and 2 is assigned to the R2. So we will subtract these two numbers and assign the result to the R0. Yeah. And as you can see, 2 is assigned to the second register. Yeah. As a result, it will assign the 1 to the third register. Why? Because the program sees that 13 is greater than 2. So for this reason, it will assign 1 to the third register and skip this part. So the last condition code which I'll talk about is less than or equal. Less than or equal, so here is also an example, negative 40 and negative 10. So it will also check if negative 40 is less than or equal to negative 10. So if it's correct, it will assign the 1 to the third register. If it is false, it will assign 0. Yeah, less than or equal, negative 40 and negative 10. So let's run this program. Yeah. Yeah. It will assign 39 to the R1. Why? Because it used 2's complement and it changed the negative 40 to the 39 as a result 2's complement, and also 9 is also here. So we will check if the numbers, if the number of the first register is less than or equal to the second register. Yeah. As you can see, so the negative 40 is less than or equal to the negative 10, and this condition is true, and for this reason it will skip this part and it will directly go to this command. So it will assign 1 to the third register. Yeah. I talked about branching, NZCV flags, branching, and 4 condition codes, and I expect that you understood this topic and my presentation was helpful for you. That's all.